thank you all for coming. So, just give you some information about who I am to start off with, because I'm hoping you came for something other than the free pizza. So, you can never be quite sure. So, as Eric was stating there, I'm from Ireland. Oh, yeah, background music. Yes. You don't quite need the light jazz. I graduated from Trinity College Dublin back in '06. Then I worked in Google for about 7 years, working on various systems, and I kind of ended up as the monitoring guy because I need monitoring to do work. It wasn't my primary role, but if I wanted to debug a capacity issue or figure out a problem, you kind of need monitoring. So I was the guy who ended up fixing it. After that, I worked at a local startup in Dublin called Boxever, where I was in charge of systems and infrastructure. And from there, I actually founded my own company called Robust Perception, focused on Prometheus monitoring system, and I have over the years contributed to many, many open source systems. So when you talk to people about monitoring, they can have very, very different ideas about what you mean. I've had people wondering, am I doing employee monitoring? Like, the people who check the proxy logs to see if you're looking at Facebook during work. It's like, no, that's not the sort of monitoring we're involved. So I kind of see monitoring in this context to mean 4 things. The first of them is to know when things go wrong. So if your customers are knocking down on the door, that's something that's gone wrong. If that's going to happen in 5 minutes' time, that's something that's about to go wrong. And when those things happen, well, the second thing is you need to be able to debug it and figure out what's going on. You want to gain insight into the problem so you can fix it. On a more longer term, other than when the customers are trying, or they're at pitchforks, you'd like to prevent that, like preferably several months out. And for that, you have trending. So you want to be able to look over the last week or month or quarter or a year and say, hey, we're kind of getting close to capacity. Maybe we should do something before we run out in 2 months' time. Or we would say, hey, our cache hit rate is 20%. That means we can actually turn off some of these servers or make other business and engineering decisions. The fourth thing that monitoring is for, and this kind of varies, is kind of just generic plumbing. It doesn't quite fit, but people use it a lot. So for example, if a hard disk fails, you can't do anything in smart. At the end of the day, you have to send a human in to fix that, mostly because the robots aren't good enough yet. But there's other cases, like you might be auto QA, security tests, other things like that, where you're just plumbing through and the monitoring is just how you're making that happen. So if we're going to talk about microservices, there's a few things that are kind of different about microservices compared to other more traditional architectures. One is that you might tend to have many, many small services. Normally, you might have 5, 10-ish services that are monolithic. Microservices, you could have tens of services, maybe hitting 100, depending on how broken things out are. The services are all talking to each other, rather than one monolith that's just talking to itself. There might be a whole pile of languages involved. Like you might have Ruby and Python and Node and Go and C and C++, and maybe someone's even used something a little esoteric. And of course, because there's all these microservices there, and you already might have tens of them already, well, there's lots being added and removed all the time as things are being refactored and changed. So it's a quite dynamic environment. And then the thing is that if you talk about what you need to do to monitor a microservice, let's look at what more the common monitoring problems people have are at all for any system. So in my context, in my company, and just as an open source developer, I've talked to lots and lots of companies, and there are some common trends that are, well, common. Monitoring tools that are out there, they tend to be very limited. They're limited technically, and they're limited conceptually, as in they force you to think a certain way, and that certain way isn't necessarily very good. They don't scale well, and they're generally just really, really annoying to manage. And generally, these result in the fact that the way you do things just doesn't align with the business. It doesn't make sense. Now, the example I always use is this. If you have a system like Nagios that can only alert you when CPU usage is too high, and what you actually care about is end-user latency is too high, you've got a mismatch there. Because yes, maybe CPU usage is 95%, but that's just log rotate. It'll clear in a few minutes. But maybe also you've got a deadlock, and CPU usage is low, but your latency still sucks because you've got a deadlock. So this is not a great method because there isn't great correlation. So on top of microservices, add additional challenges on top of it. So if you're adding and removing services all the time, that needs to be pretty low friction. If you have to submit a form and wait a month or two for your ops team to take care of that, that ain't going to fly. You've also got machines that being added and removed all the time. So you're going to want that to happen completely automatically without any human intervention, preferably. There's also going to be each team, because they're managing their own services and making their own architecture decisions, then each of them also has different requirements and different ways they look at the world. Having one operations team in the center or centralized monitoring team deciding what the world looks like, not really going to work out. So how do we support all this? So what we kind of need to look for is a monitoring designed for a dynamic microservice environment, right? It needs to support all the languages you have, all the systems, all the server types, all the databases, whatever else all your teams have decided to use. And allows you to decentralize that across your teams. And, we want to be able to do a nice bit of math across it. And if you do have commonality between your services, because you are using common RPC libraries, right, at least in one language, you should be doing that. When you do have common services, like common libraries like that, you want to take advantage of the fact that, hey, everyone's using the same library. Let's take advantage of that to make everyone's life easier. Because the thing is, a lot of monitoring systems, when you look at them, they have a big black cloud that you can't see what's going on inside them. You can see it on the outside, yes, there are requests coming in. We're getting so many requests per second to this endpoint and that endpoint with so much latency. And the other end is talking to Postgres. In the middle, we're not sure, but we think it works. Because, there's still some pitchforks for sale. So the thing is, though, that in reality, services have internals. Just like your microservice architecture kind of looks like a tree, the internals of your service is a whole pile of subsystems that look kind of like a tree. So the idea behind Prometheus is each of those subsystems is instrumented, and then you pull that all out via Prometheus. The second idea is that you don't think about machines, you think about services. Because fundamentally, I don't care that this machine is running your service, because it's just one of many of those. And obviously, in a microservice architecture, you might be multi-tenant on a given machine. You want to just think, no, one machine doesn't matter. It's the whole service and how it affects it that really matters. One machine being slow is not a problem, unless it's so slow that it's dragging the rest of the service down enough to matter. Because you don't want to be woken up in the middle of the night by one machine that's, it's not performing optimally, but it can wait till the morning. So Prometheus itself is inspired by a Google monitoring system called Borgmon, which is well over a decade old at this point. It was started by ex-Googlers in 2012, the project, as an open source project by SoundCloud. And it's mainly written in Go because they were having problems with Statsd and Graphite. It was publicly launched in 2015, and it's completely independent of any company. So I've been wondering, ex-Googlers creating this. This is because when Googlers leave SRE and leave Google, they just recreate Google technologies. It's just kind of what we do. I personally have been involved in 5 such projects. Prometheus is just one of them, although the one which I've most seriously done it. So since it launched publicly back in January 2015, hundreds of companies are using Prometheus in production. And I don't mean that one guy is running it on his laptop for fun. I mean more than one person in the company is using it, which I think is a much more reasonable definition. It's also a very active open source community. We have over 250 contributors, just to the official repositories, and then there's over 50 third-party tools you can use with it as well, which I think is kind of cool. So the idea I'm going to try and push and talk to here is that we don't have that big black cloud, that we actually use inclusive monitoring and monitor everything. So if you have your RPC library, right, then one person on the client side instruments it once and everyone can use it. The matching library on the server side, once again, someone instruments it once, everyone gets to use it. Your business logic, hopefully not copied around quite as much, but once again, someone instruments it and you get that information for your system. If you have, say, your client library for RPCs instrumented and common across your entire infrastructure, that leads to some handy bonuses. For you as a developer who's using this library, this is pretty handy because it means you're going to get some monitoring for free because someone's already created the dashboards. Someone's already created the alerts and rules. The other benefit is actually as the library author. Let's say that I'm trying to make some decision about compression and I'm the maintainer of the RPC library. I can add in a metric or two that will help me with this, let that propagate out via the release cycle, point some Prometheus servers at everything, pull in those just 2 metrics I care about, and do some math, and then make a trade-off for CPU versus network, or everything else. So that sort of horizontal monitoring is also an option when everyone's using the same libraries. We've talked now just about adding in the instrumentation, but then, everyone hates having to write code, but someone has to do it. It's great to say, yes, let's just tie the bell onto the cat's neck, but who's actually going to do it? So Prometheus clients with which you do instrumentation are not the same as most clients out there. We don't just marshal data and chuck it over the wire. We actually provide an instrumentation library to make your life easier. It takes care of things like concurrency and state tracking and bookkeeping and all the other things you need to worry about taken care of for you. Where possible, where a language is powerful enough or has a feature, we'll take advantage of it. So for Python example, context managers and decorators make our lives easier and make your life easier. So let's take this example here. This is a complete example of using Prometheus client library from Python. You pip install Prometheus client. You import stuff, pretty standard. The next line then is creating a summary. So this is the way to track latency here. And you'll notice here it actually has a description, request duration in seconds, because that's helpful to figure out what this actually means, which matters a lot when you start having hundreds to thousands of metrics across your system. Because if you're doing this right, you will have that many. And then we just use the decorator to time this particular function, which does nothing because the slide is kind of limited in height. And then we just expose it over HTTP. So that's how easy it is to time how long all the calls to that function takes. Effectively 2 lines of code when you ignore the boilerplate, which I think is pretty cool. Similarly, as other common cases, not just timing things, you want to count the number of exceptions, and you can say this particular type, and how many requests are currently in progress. All pretty easy to do, because we know these are common use cases, so we've made them easy. There we go. And the other thing is, like, you're thinking, awesome, this Prometheus thing, I want it right now, go out and use it across all the languages. But, vendor lock-in. Because, that's always great to have. But the thing is that I have a very strong stance on this, which is that we don't lock you in. You can use Prometheus client libraries and not use any other component of the Prometheus ecosystem. So you can actually, at least Python and Java have implemented this so far. The APIs are there for everything else. You can actually output the graphite. So with 3 lines of code in Python versus 1 for HTTP, and in Java, it's actually easier to do graphite than HTTP, the official way for Prometheus, mostly because setting up servlets is annoying in Java. Whereas, I could make things easier for graphite. So if you want to take advantage of these stuff and not ready for Prometheus yet, but you're still using graphite, off you go. The libraries allow for it. Maybe in future you use Prometheus, maybe you won't. Maybe you've got some different monitoring system. Write a few lines of code, output it to there instead. So this gives you lots of options. So you can take advantage of all these benefits without being tied into Prometheus itself. And it goes the other way as well, because let's be honest, Prometheus is unlikely to dominate all monitoring in the foreseeable future, as much as I wish otherwise. And as much, hopefully, by the end of this talk, all you will wish so too. So we have lots of things that will convert data the other way, whether it be graphite, StatsD, SNMP, JMX. You can take data in from those and output them to Prometheus. And then the other things we can do is that if you have an existing binary that does Prometheus stuff, you can read that in, parse it, and chuck it out to graphite. So an example of this is Zalando Zmon. Zalando is a German startup who do clothing in Europe primarily, not Ireland, even though they have an office there. But I think Nagios written in Python to scale. But it itself does not use Prometheus. However, Zalando are running Node Exporter, which is our machine machine exporter, and they just pull some stats from that via the Python client and alerting them. There is no Prometheus in this loop, but they get to take advantage of the fact that we figured out how to monitor one particular system and pull that into their monitoring system for free. Because one of the problems I have as an open source monitoring system author is that, well, great. I told you there was like 50 different integrations out there, probably about 60 or 70 by now. Those all have to be written for Prometheus, and New Relic, and CloudWatch, and Datadog, and OpenTSDB, and CollectD, and this is just silly. Every single monitoring system out there needs to implement all these integrations. And that's an N by N problem, that's silly. So one of the things I'd like to propose is, hey, let's get one standard, and then have it as a clearinghouse and spit it out to whatever you want. And as well, as I mentioned, there are lots of integrations. For example, we support Minecraft. So if you want to monitor how long those ticks are taking, what your frames per second is, off you go. You can do that. as well as the more practical stuff, depending, of course, on how much you value your ledger, like CAdvisor, Java, JMX, Python, MySQL, Postgres, CloudWatch, anything else like that you want. And interesting as well is most of these were created without the core team knowing about them. We only found out after people are already using them in production. So that gives you an idea of just how easy they are to write. And also why we now have guidelines on how to write them, because there are some things that are a little non-obvious about writing them. So another aspect of Prometheus compared to those who are used to graphite, I assume most people here have touched graphite at some point. Yeah. So it'll use dotted strings. So this example here, if I have something, a metric about tech in Dublin, it'll be metric.tech.dublin. And these can go on so long, and it might say, oh, the region is this, it's Canary or Prod, and so on. And you kind of have to know which field means what. Prometheus instead actually uses structured data, labels for this. There's a few other systems like OpenTSDB, Netflix Atlas, I think Datadog has it, New Relic has some way, but most systems are still on dotted strings, which is a bit of a problem when you're trying to look them up. Because you have to remember which field means what, and hope that no one put a dot in anywhere to mess things up. Because it turns out most people don't know about escaping and sanitizing. But the advantage of this is that because it's just key value pairs in a map or a hash, you can look them up any way you want. So it's much more powerful rather than having to use globs. And the other thing is that these can also come from instrumentation. Like if you think about your OPC library, it might be which method or endpoint you're using. Or it could be coming from the service, like, oh, this is Canary, or this is Europe, or this is EC2, or whatever. So it can come from both. And those are merged and unified, so you can get them either way. So if you want to know, hey, how is the /fetch_me going across everything, you can. Or if you want to say, hey, how's the entire prod doing, you can do that as well, because it's all one unified namespace. So here's an example here. We've got a metric called node network received bytes. So that's the number of bytes being received in the network interface. Devices here, so this is in a Docker example. So we've got a Docker 0, ETH0 low. It's all on one machine, which happens to be 192.168.173, and it's a node, is the job. So you might have hundreds or thousands of these, depending on how many machines and devices each of them have. Then if you're going back to the instrumentation example, it's about 20 bytes to add in a label. So this stuff's really easy to do. You do have to declare in advance what label names you want, just because you don't want to know how difficult it would be if you didn't do that as a user. Because that just makes life really hard for later analysis if you haven't chosen them. Another interesting thing there, you'll notice that the numbers here are kind of big, particularly for low and ETH0, because that's clearly not what I did inside the last minute. So Prometheus has a notion of a counter. A counter goes up. Yeah, goes up. Unfortunately, not all systems go up, which is a little problematic with their counters. So by the fact that the counters only go up, we can do something to increase our reliability. Let's say that we're doing scrapes, right, every minute, and one of them fails. For whatever reason, the network's dodgy, someone hit off a cable, maybe the server was overloaded at that moment, and we miss a scrape. But we know the total count from the previous scrape and the next scrape. So we can tell, oh yeah, we can kind of tell what happened there. So we lose some resolution, but we don't actually lose information. That's kind of handy. There are other monitoring systems out there. There's a few different approaches. I've got a blog post on this. That, for example, every 60 seconds they'll push what happened in the last 60 seconds. So if you lose that push, well, you've lost it. Good luck. There's other ones that will reset every time you scrape, which is real fun once more than one thing tries to scrape. So this approach is much more resilient. The one challenge you have is that if the server restarts, everything goes back to 0. So you need to be able to detect that, which Prometheus does. And that's all fine, as long as counters only go up. Because if counters go down, we can't distinguish between a counter going down and the server restarting. So that's why it's really important that counters only ever go up. So now we've gone to a little data model. We've talked about the instrumentation, getting all the data in. That's great. What do we do with it now? Like, do we print it out and stick it to our fridge? No. So we've got more powerful options. We've got a language called PromQL, which you can do basically anything with. I think we're almost got a complete feature set at this point. So you can multiply, add, subtract, divide, multiply, do label operations, anything you want. So if I want to answer the question of what's the 95th percentile latency in the European data center, I can. Or how full will the disks be in 4 hours? Now, anyone who's ever set disk full alerts will know that they are noisy and annoying. Because there's basically two approaches to setting them, two normal approaches. One is you set a threshold, like 5 gigabytes free. The other is you set a percentage, such as 5% free. The problem is if you set 5% on a really, really big disk, that's very wasteful. But if you set it on a really small one, it can fill up in no time. And you've got the exact opposite problem with using the absolute amount of 5 gigabytes. With Prometheus, you have an option of using linear predictions. So we can look at over, say, the last 4 hours of data, do a least squares regression, and see that, hey, we think in the next hour is going to be X full. And if that's over 100% full, then page. So that's a much better way of doing things. It's not perfect, obviously, but it's still far better than static thresholds. And other things you can do, like if you want to know the top 5 uses of CPU, like say by Docker image or something, no problem. You can aggregate these in any way you can think of. The other important fact is Prometheus makes no distinction between graphing and alerting. If you can graph it, you can alert on it. You just need to add a filter. So here's an example here. So across this entire Prometheus server, whatever it's monitoring, which is probably an entire data center, we're going to take a rate, because that's a counter, of everything running in Docker, so it's saying the system/Docker, averaging that over 5 minutes, added up by image, so this is across all Docker images, so this is across all machines, across all containers, across all apps, everything using the same Docker image. Give me the top 5 for CPU. So that's the sort of aggregation and power you can do. And this is a simple example. In fact, this is one of the more complicated examples you run in day-to-day usage. So it's nice and all to talk about Prometheus, the language, and so on, but if it takes you, if you have to sacrifice a chicken every time you use it, that's not going to work out too well. The good news is we do not require either human or animal sacrifice to use Prometheus. So Prometheus itself is a single binary. It's Go-based, it's easy to run. It has no network dependencies, right? It doesn't depend on Zookeeper, Console, Cassandra, Hadoop, or the internet. Because think about it. If you've got a network partition or other problem, do you want your monitoring system falling apart, or do you want your monitoring system doing the best it can? If you've got something like a Kafka queue there, that's a CP system. And it's going to fall apart as soon as you have a network partition. Prometheus, because all it depends on is local disk and network access, it's just going to keep on chugging along as well as it can. So if you've got one of them on each side of the network partition, hopefully at least one of them can get alerts out and page you, which is kind of handy for debugging. And as I discussed there, it is state rather than event-based, so if you lose a scrape, all is good. It's also decentralized, so Prometheus is pull-based. Now, a lot of monitoring systems out there are push-based, which has pros and cons. Pull also has pros and cons, but it does mean that if I want to test out a Prometheus on my own, my workstation, I just turn it on. And can dare and see the exact same thing as what's in production. So that's really handy for development. It also means if I want to do HA, I just run a second one. It's identical, all works, simple. No clustering or other things like that which can fail. But because it's so simple, that means each team can run their own. I mentioned earlier how each team can have their own view of the world. With Prometheus, you just give one of them each. Or potentially also have it inside one Prometheus server, but let's be honest, everyone will want their own. Now you might want to ask the question, if this is all pull-based, how do we know what to go and scrape? Because with push, well, everything kind of just finds the monitoring system. With pull, that's obviously not going to work out. So we've got service discovery that can look at EC2 or Console or Marathon or Zookeeper or whatever else you have and get a list of all the targets, and then you can use relabeling to basically figure that out. Because one of the problems we have is that everyone has a different view of the world. In any given company, there is probably between 10 and 100 different ways that each team views how their systems are organized. Like an infrastructure team is going to say, yes, this machine, it's on rack foo in data center bar. That's it. And if their infrastructure team, they win is what things are called. However, the database team might say, no, no, no. That's the canary server for Team Baz. And Prometheus, both of those worldviews are possible, even in the same Prometheus or in different Prometheus servers. So you're not being dictated by what the infrastructure team have decided, which is kind of handy. Now, as well as being easy to run, it's also extremely efficient. So our new var-bit encoding is down to 1.3 bytes per sample on average. That's actual production data. So this is actually based on Facebook's Gorilla encoding. We tweaked it a little bit to get it slightly more efficient for the constant use case, so slightly more efficient. And as well, a single Prometheus server can handle 800,000 samples per second. For context, that's probably enough to handle 10,000 machines worth of load. So that's a lot. But suffice to say, it is unlikely you will ever need any horizontal scaling on this because it's so efficient, which is kind of handy. In the event that doesn't work out, there is a way to do horizontal scaling. It's just slightly annoying. But most of the time, we'll just say vertically scaling. So you just give each team their own, and that'll last them forever. Now, of course, with all these Prometheus servers all over the place, you're going to ask, how the hell do I get my data? It's going to be all over the place. So there's federation to allow you to pull aggregated stats from other Prometheus servers. Or more commonly, if you've got a data center Prometheus and a global one, you can just pull those all up for one central view. But for anything important, it's still drop down to the data center one, so you can get all the detail. There's plenty of dashboarding options. So on the left, we've got the built-in expression browser. It's good for ad hoc stuff. You wouldn't use it for anything else. On the right, console templates. They're really powerful, kind of hard to use because it's a full web templating language. In the middle is PromDash, which is an older system, which is Ruby on Rails. That's all your pointy-clicky stuff. These days, we use Grafana and recommend that. So we have first-class support inside Grafana. So if you use that already with Graphite, same setup, drop in a query, it works. And the Rain Tank guys who produce Grafana are very, very happy about Prometheus. So it's going to get tighter integration in the future. So what we've looked at so far is the instrumentation for a variety of languages easy to use. We've got a pretty nice data model and a way to look up data. Alerting is also pretty awesome. Every team can have their own thing, their own view of the world, without having to be bottlenecked by a central infrastructure team or a central monitoring team. And as new services are added and removed, and even as the machines are added and removed, things automatically are being picked up, as long as you set it all up right. So this means Prometheus is a pretty good option to monitor your microservices. So I've also want to go over some just general tips for monitoring microservices. Now, these are not Prometheus specific. These apply to anything out there that you have, just so, some things you've learned over time. Because when you start getting lots of data from all these different microservices, it can get a little overwhelming. And just like you architect your software, you need to architect your monitoring, just so you can think about these and scale it up. Because, if you try to do things in an Eve way, that's going to be ON, and that just doesn't work as you get more machines and services. So the first tip I say to you is know what your key statistics are. Users do not care in the slightest, going back to the previous example, that one of your machines is overloaded. That is irrelevant. What they care about is that your service is slow. So that's a statistic you should have on your dashboards. Now, you can debug and figure out that, the service is slow, but that's really what you're at the top level. You should be caring about the same things your users do. Similarly, related to that, once you start having, let's say, lots of services, each with lots of machines, having each of those as a line on a graph isn't going to work out. Our brains are limited in capacity. We need to realize this fact and appreciate it. So rather than having a line for every service and every machine, have a line for every service. That's going to be, in this example here, like an order of magnitude less data to process. And once you figured out, it's the web service that's broken, then you can look further down and see, yeah, it's that machine. It's dodgy. Kill it. But it's just like thinking about how do we change this operation from an n by m to a log n solution. And that's the sort of way to think about it. Similarly related to this is avoid what I call the wall of graphs. This is where you have a dashboard that just, it looks awesome, but it's utterly unusable. So the one I've personally seen was worst had 600 graphs. And this was declared to be an awesome dashboard because it had all the information. I never figured out how to use that dashboard. The worst I've ever heard about happening was 1,200 graphs. Someone had a reference of some talks where someone mentioned this. Yeah, humans can't deal with this, right? You'll be lucky if the person who created this dashboard can even use it a week later. It just doesn't work. So what I say instead is you've got a microservice architecture. It looks vaguely like a tree. Hopefully no cycles, maybe not. So what you do is, let's say you've got a problem like high latency. You start at the top. You look at it and say, is this service overloaded? No. What about its backends? Oh, that one's slow. Grand. Look at this dashboard. Is it overloaded? No. What about its backend? Ah, this one is. This one's slow. This service, is it overloaded? Oh, it is. Grand. Let's look more at this service. Is it a particular machine? Is it a subsystem of the service? And so on. Once again, this is taking a log-n approach rather than just throwing all the information and hoping that someone doesn't fall over from overload. So it's a much more scalable thing. So what I found is a good rule of thumb. For every single dashboard, no more than 5 graphs, and no more than 5 lines on each of those graphs, preferably only 1 or 2. You can get away with more with stacked graphs, and tables with like 20, 30 stats on the side are handy as well. But this will generally provide dashboards that are pretty easy to understand. If you find yourself going over that, you need to either trim or break things out. Getting then a little more into math, quantiles cannot be aggregated. It is statistically impossible. There's lots of these fair few systems, and Prometheus is among them, which offer client-side quantiles. This is where the instrumentation library inside your process calculates a quantile. We're not going to discuss how that's done, which is also kind of interesting. But let's say this is correct and has the right properties. Then you have this quantile, say your 95th percentile latency across all these servers in your monitoring system. What mathematical operations can you actually perform on these that are meaningful? The answer is there are none. Not possible. You can take a min and max and kind of get bounds, but that's about it. You can't take an average because that's wrong. Because you don't know, like if one server is particularly slow, then that's where your 95th percentile latency is going to be. You can't take an average, you can't weight them, doesn't work. If you actually need quantiles, the way to do it, and the Prometheus Histogram does this, as distinct from the summary, create buckets. Like 10 to 20 buckets is normally enough, and just count how many queries are, let's say, lower than 10 milliseconds, slower than 20 milliseconds, slower than 40 milliseconds, and so on. Take those up, those are all counters. Those can be aggregated. Those can be aggregated across machines, across services, across data centers, or globally. And then based on that, you've now got your histogram and you can calculate a quantile. That's how that works. So in Prometheus, this can be done using histogram, quantile, and rate. Just something to be aware of, though, with other monitoring systems, there's very few that get this right. Another one is, well, quantiles and percentiles can be a bit misleading. So I've got a question. I have a simple service with 2 backends. Now, my 95th percentile latency on the front end has gone up because one of the backends has gotten a bit slow. If I look at the 95th percentile latency on the back end, what will I see? Are there any guesses? No guesses, which is actually the correct answer. Because the answer is, it depends. It entirely depends on how the query requests are correlated between these two and which ones are causing it to go slow. A 95th percentile means you are throwing away 95% of the data. And if you're doing that at 2 different levels, there's no guarantee it's the same 95% based on queries. So that means that it's really hard to figure out what's going on. And in an emergency, trying to reverse engineer this and figure out these correlations, good luck. Not going to happen. The good news is averages don't have this problem. So if you have ascertained that there has been a latency increase via percentiles or whatnot, averages are always going to show that up. So if your top level, if you see a 50 millisecond increase in latency due to a backend, if you look at that backend, you will see a 50 millisecond increase. Maybe 49, maybe 51. But you will see it. So keep that in mind. Averages are very easy to reason about. They don't have all this complex math in the way. And as you get more and more complicated systems, you kind of want to keep things as simple as possible. Now, maybe once you've determined which services to blame, you can look again at your percentiles and see what happens. Because knowing that, oh no, it's only the slow queries or the fast queries that are affected is kind of useful. Another one then is you need to consider costs and benefits. It would be awesome to have 1 second monitoring of anything, or even 100 millisecond monitoring of everything. But is that really worth the resource cost? Like when we're down getting onto 1 second monitoring, we need to worry about things about how much CPU you're using on the client. Like I would say, let's say if you have 1 second monitoring versus 10 second monitoring, is that really 10 times better? Because it's going to cost you 10 times the resources, both humans and machine. And I'd say no, it's probably maybe 10, 20% better. Similar between 10 second and 60 second monitoring, maybe 20, 30% difference there. So just think about what these trade-offs are, how much money you have spent monitoring, and what works well. Personally, I find that 60 seconds, not 60 milliseconds, that would be a very expensive monitoring system. 60 seconds is a nice, good balance and a nice starting point. If you aren't sure where to start, that's normally a good bet. There is stuff for 1 second granularity where you do need it. So there's this thing called a microburst, and that's where a lot of network happens in like 10 milliseconds, 100 milliseconds. You're never going to spot those with 60 seconds of monitoring. You can spot a fair amount of it in 1 second. But that's about the only time you really start to need 1 second monitoring, or really weird oscillations. For those, you actually want is highly aggregated stats coming from your clients, like just total query rate, not broken out by anything, and keep those at 1 second, and those are handy. Also really, really useful for load tests. But that's you only really want maybe at most 10 metrics coming from every single process at 1 second monitoring, just from a trade-off standpoint. Now, of course, you can do your own math, make your own trade-offs. This is what I've personally found to be a good approach. Once again, going back to math, there is a thing called the Nyquist-Shannon sampling theorem by Nyquist and Claude Shannon, who was, I believe, was 100 last week. He invented information theory. He also then took care of most of the field in the same paper, which is kind of awesome. But what it says is that if you're trying to resolve a pattern, a wave, and that wavelength is, say, 10 seconds, then you need to sample at least every 5 seconds to actually figure out its shape. This means if you're scraping once a minute, you can only spot patterns that are at least 2 minutes long. So this can cause all sorts of weird artifacts and cause confusion and so on. Just be aware of it. Like, well, you actually see this fairly often if you're in Grafana or whatnot, and hit refresh, and it's now like 1 second later. Like, it's still working off the same 60-second data, but all the shapes change. And that's because of the sampling issue in Nyquist-Shannon. You just don't have high enough resolution to spot what's actually going on. Now, one option here is you increase your resolution, because like weird stuff does happen. But you never know how accurate you need to go, how small a resolution. So at this point, if you do think you are having one of these problems, like a microburst or so on, or fluctuations, this is a good time to use logs. Because they will give you the exact times that everything's happening, and they have arbitrary resolution. Or at least they should have arbitrary resolution. I'm not sure if I've ever seen an issue that's sub-millisecond. That probably happen, but they should be good enough for that, because there are limits to what you can do with metrics-based systems like Prometheus. The other one, so correlation is not causation. So we're good for time? Yep, checking. Grand. Because I skipped this otherwise. So I have a rule in my head. Now, some of you might have heard this before. And you'll give me a sequence of numbers, and I'll tell you if it conforms to the rule, right? So I'm going to say that 2, 4, 6 conforms to the rule. So let's just take the 4 people in front here. Guess, you can tell me sequences of numbers, and I'll say whether they conform or not. Don't be shy. Anyone? Sequence of number. 2, 2, 2 does not conform. 1, 2, 3 conforms. 6, 8, 10 conforms. 1, 10, 100 conforms. 20, 40, 60 conforms. 6, 4, 2 does not conform. So the interesting thing, does anyone like to make a guess at the rule? Pardon? Monotonically increasing, yeah, basically any non-decreasing sequence. So you'll notice a lot of the questions that were asked there they all got a true answer in the conforms, because humans are really, really good at spotting patterns, particularly patterns that aren't there. We aren't good at spotting that actually a pattern mightn't be there. Like, it's not unusual when you ask this question, and to be honest, asking it to a large group really biases it in your favor. People come up with rules like they increase by 2, or they increase by 3, or who said it has to be 3 numbers, right? These all need to be thought about. So you need to allow for the fact that humans are really good at recognizing patterns that aren't there. So anytime you see a pattern or a correlation, think about, well, if this is true, then it also expects to see X, and is X happening? So if you were looking at a graph and you see, like, oh, this is spiking and this is spiking as well, that's a correlation. But is it causation? Maybe those are just 2 cron jobs running on the same schedule, and it's just pure chance that it happens to be running at the same time. Maybe if you look back for the last 10 runs, they've never correlated before. So it is pure chance. And the other one to be aware of that is actually fairly common is there is some causation there because they're two batch jobs or something, and one of them is slightly increasing contention, which is just enough to push the other one over the edge. So you're actually having a load issue. But look out for this sort of things. Always look back in time, zoom out a bit, see what's happened. Is this a regular event, or is there actually a correlation there? Because if you look back and see actually 90% of the time these two do correlate, that's a pretty good sign. Another one is that Prometheus is a metrics-based system, right? We don't do logs. And there's lots of things out there. There's advantages and disadvantages to each approach. They're complementary. You should really have both. Because the thing is, logs have information about every single event. But this means you're kind of limited by bandwidth to how many fields you can have in a log to maybe 50, 100 before you just run out of bandwidth. But you can have any values you want in there, any cardinality, no problem. It's a batch processing system to actually handle that. Metrics, on the other hand, they're aggregating across time to give you a counter. So you can have many, many metrics. You can have 10,000, 100,000 metrics, no problem. But you really need to limit that cardinality for the same reasons. So they kind of focus on different things. Metrics kind of give you a high-level overview of what's going on. And you'll be able to figure out that, oh, yeah, it's the GET requests to the /foo endpoint that are the problem. And then you can look at logs and say, oh, yes, and here are the customers that are articulating that problem, ask them to stop or fix it. So metrics are good for zooming in on what the problem is, and logs are for figuring out, OK, we now know what the problem is, which queries are the problem, or that sort of thing. So they work together. In the same way, the metrics and then profiling. But using entirety metrics or entirety logs is not really a good approach, unless you have to choose between one because you've got no other choices due to limited time. But try to have both, each of their strengths, each of their weaknesses, and they complement each other nicely. The final tip is a bit more organizational. There are going to be lots of alerts that just don't justify paging someone. Like, hey, we're at 70% disk rather than 90%. Or we're going to fill up disk in a week rather than 4 hours. And what normally happens to alerts like this is they're sent to email to a team mailing list, and then everyone who's part in the team, which is hopefully everyone, will filter them away or delete them, never to be seen again. Until the outage happens, because there's always an outage. And it turns out one of those emails that everyone was ignoring, it heralded a problem, and if someone had looked at it, we'd have all been good. And of course, that's one of the 10,000 emails that was received that day. So, well, actually, to be honest, the worst I ever saw personally was about 1,000th in a day. So what's happened here is got a whole pile of alerts. They're going to, somebody will look at them, honest, and they're just going into the void. And they're being ignored because the signal-to-noise ratio is atrocious. Because there's no incentive to not have these alerts, right? It's easy to say, case of emergency, you want this alert. How you handle this, in the same way that pages, you make sure that someone gets them because you've got someone on call. These, you also want some solution that is credible that someone is actually following up on them. So there's two approaches I've seen to generally work. One of them is you send these alerts to a ticketing system and make sure they're being taken care of in however way you normally handle tickets. If most of those tickets are getting resolved with it's not happening anymore, then it's time to adjust your thresholds in the upwards direction. The other approach I've seen work, this is less common, is once a day have an email, or 12 hours depending on how your shifts work, that says here are all the current firing alerts, and then the on-call just processes them all once a day. I've also seen that work. I have only ever seen one team who ever managed to do straight email for alerting. And then that team split in two, so there were two teams who were doing it straight for alerting. But that's the only time I've ever seen it happen. So it doesn't work once you get beyond like 2 or 3 alerts. But these approaches do work. The final word, just because monitoring, especially when you're using something like Prometheus, which allows you to instrument everything, or any other system, is that you can overcomplicate things and get in over your head, just as with any other technology. Keep things simple, right? If you find yourself creating big, long, complex systems or having to spend a lot of time just running your monitoring system rather than running your actual production system that your customers are paying for, then it's time to simplify. Monitoring is a means to an end. It is not the end of your end goal of your company. So keep that in mind, because you should only be spending maybe 10%, 5% of your time on monitoring itself. If you're spending more than that, it's time to simplify. There's probably a simpler solution that's good enough. Just to say as well, my company, we help with Prometheus and monitoring generally. And if you want to contact me, there's details here, as well as Prometheus website. We've got a demo and any questions, and we'll just do the quick demo. So this is demo.robustperception.io, which is live. Oops, there's it. Here's some actual monitoring output from the node exporter. So here's machine stats. Yeah, we've got lots of them. So here, for example, you can see how much time is being spent reading disk on dev VDA. There's only one SSD in this machine, so it doesn't look very interesting. And you can see that's a nice big number. Here is the expression browser. So this is handy for ad hoc graphs, but you know, it's not the best UI ever. And there's also Grafana, which is much prettier and point and click. So here's the Prometheus itself. And in the top left there, you can actually see the spike where I was accessing the data a few minutes ago. And just to show you an idea of just how powerful the Prometheus query language is, this is Conway's Life, implemented in Prometheus query language, and then rendered in consoles templates. For those of you who didn't study computer science, Conway's Life is known to be Turing complete on a much bigger grid than this, which means that if it is possible to compute something with any programming language, it can be computed with Conway's Life. And because I've implemented Conway's Life in Prometheus, that means it's possible to do any computation that is computable inside Prometheus. Please don't do this in production. Cool. Okay. I'm sorry. Cool. So do we have any questions? Yep.
So you say it's only based. So if I'm sending log events and plugging in stats D, I can pull something.
Okay. So the question is, if I'm sending events to statsd, do I need to send something that's statsd compatible? So we have something called the statsd exporter, which can take in data in statsd form, optionally try to pick out labels out of it, and then Prometheus can scrape that. Unless you're actually using PHP or something else CGI-based, it's better to directly instrument. Because the problem with the statsd approach is it's sending a UDP packet for every event. And when the Prometheus philosophy, a single user request or whatever other requests are coming in should probably be hitting about 100 metrics, just as it passes through all the libraries that's going through the system. You start generating 100 UDP packets per incoming request, that's going to take out your network. So the way Prometheus works is that it just has counters in memory. And then you come scrape those once a minute or once a second or once every 10 seconds or so on. So where statsd is useful is where there is no multi-threaded binary sitting there that you can maintain memory state in, such as PHP. Cool. Any other questions? Yep. Okay, so the question is, how does the service discovery work typically with the pull model? So let's take EC2 service discovery. I assume most people here are familiar with EC2. So you go to EC2, and once every, I think it's 1 minute or 5 minutes, we go and say, hey, give me a list of all the instances. And we get like all the tags, which includes its name, we get the security groups, we get the VPC ID, all that information. And then those are all given to the user in relabeling. They can access those all as basically hidden labels. The user can then use relabeling to copy those into the labels that will actually be used. And they can also filter them and saying like, hey, only labels that are, if the description, for example, matches this regex, keep it, otherwise toss it. And the other ones work the same. So if you're using console, exact same principle. It'll go and say, hey, give me a list of all your services. We come back, then you start filtering on them and copying over the labels that are relevant to you. Because like maybe your team has decided a tag called env is product canary, and you want that in a label called product canary. Or maybe you put it in the description field. Or maybe it's based on security group. Or maybe it's based on VPC ID. Whatever you have, you can manage to convert that into something that's meaningful to you. The problem we have is that because this is so utterly non-standard, our only option is to offer an interface that's this generic. Because otherwise we'd end up with, well, SoundCloud default, SoundCloud team A, SoundCloud team B, SoundCloud team C, SoundCloud team DA, SoundCloud, and that's just SoundCloud. And then we have every other company with their own variants for all these options. So that would obviously not work. You'd have a combinatorial explosion of flags. We tried to do this. So instead, it's just like, yep, here's your set of labels, and here's some operators to move these around with regexes. Next question. There's another one over there, I thought. No, oh yes, question there. Yeah. Okay. So are there other agents for things like machines and databases and Docker? So for machines, we have the node exporter, nothing to do with Node.js. That will basically dump large proportions of /sys and /proc. For Docker, your main option is CAdvisor, which directly exports Prometheus metrics. For databases like Cassandra, you'd use the JMX exporter. MySQL, we've got a great exporter, like the Racona guys, who are like the MySQL consultants. They've done a lot of work on it. In fact, they've also released their own monitoring solution on that. There's a Postgres exporter. People have been talking about an Oracle one. I think there's a Russian company that's built one internally but not contributed it back yet, but they do plan on. There's a Redis exporter, there's a memcached exporter, there's probably more. But these things are generally fairly easy to write. As long as the system exports some form of interface we can get the metrics out of, we can convert it. Because generally the way to view exporters is we wish everything was directly instrumented, but in reality it isn't. So exporters are like just little proxies. You send in the request, it goes like, talks to MySQL, gets the data, munges it, chucks it back out again. Cool. Next question. If there's another one. Okay, I'm not seeing any more questions, so thank you very much.